This is a chemistry analyzer doing tests on blood samples of patients here at Children's Hospital in San Francisco. This high-tech device can do in about 10 minutes what it used to take one human lab technician about 8 hours to do, and with greater accuracy and reliability. What it is essentially is a robot run by a computer. Just one example of how computer technology is changing medical care. Today, we take a look at the role of computers in the practice of medicine on this edition of Computer Chronicles.
The Computer Chronicles is made possible in part by the Software Publishers Association, which reminds you it's a federal offense to copy software. The SPA provides information on how to stay software legal. Funding is also provided by PC Connection and Mac Connection, and by Byte Magazine and Bix.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and with me this week is Heidi Roizen, president of T-Maker Software. Heidi, I have here a computerized insulin pump. This takes the place of the daily shots a diabetic has to take. It's actually a computer. In here is a CPU, 8 ICs, 3K of memory, and in fact a transmitter which reports out its status to one of these little handheld terminals that the patient has. So you can check to see how much insulin is left. You can change the diagnosis. It's really quite a fantastic use of computer hardware to treat a medical problem. Back here on the software side, we have Dr. Edward Perper. Dr. Perper is Associate Chief of Cardiology at the Santa Clara Valley Medical Center, and you're developing some software. Tell us about it, Dr. Perper.
This is a HyperCard program being developed at the Stanford Medical School at Summit. This is a program designed to teach medical students how to take care of patients with common medical problems. On this screen, they can ask various questions of the patient, for example, what the problem is, and as you can see, they can ask many other different kinds of questions. After they're finished talking with the patient, they can go ahead and do a complete physical examination. They can go to the chest, the abdomen, do exactly what a doctor would do in a physical examination. Once that's complete, they can go ahead and order laboratory tests, chemistry tests, x-rays, EKGs, etc., and order those tests and find out what the results are. And once they're fairly sure what the patient's problem actually is, they can go ahead and order various kinds of treatments. They can tell the patient to stop smoking, they can order various kinds of drugs, and even send the patient to surgery. And once the session is complete, they can find out how much it all costs.
Right. Thanks very much, Dr. Perper. What do you think, Heidi?
Pretty incredible. I think the application of technology like this to medical education is really going to dramatically improve the kind of education that they can give.
Yeah. Well, we're going to take a look at a variety of applications in the medical field today. We'll see how doctors use computers to improve diagnosis. We'll see how medical schools are using computers to train young doctors. We'll visit an ophthalmologist who uses computers to treat retinal disease. And we'll see how computers are being used in the battle against breast cancer. Now, with all these computers and all these doctors, there has to be a professional association, right? Indeed there is, and we're going to begin today with a visit to the annual conference of the Healthcare Information and Management Systems Society.
Patients generate a lot of paperwork during their stay at hospitals. A recent meeting of healthcare professionals in San Francisco provided a clear indication that the trend is toward automating that work and creating a paperless hospital. Bedside terminals made a strong showing at a meeting of the Healthcare Information and Management Systems Society. The cost for a single terminal can be prohibitive for small hospitals, but the system tracks a patient's complete treatment and can even print a copy of the prescription ordered by the doctor. To differentiate their systems, other vendors have added little accessories like a mailbox or calculator. One bedside terminal even has a barcode reader.
Patients often generate thousands of pieces of data during the course of their stay, and at any one point in time, only a very small subset is of clinical relevance. So systems that assist the provider, perhaps through the use of expert systems, in identifying key pieces of data will eventually win.
A concept that's been catching on is the handheld computer. This one, customized for a respiratory care unit, can store profile, activity, and order details for each patient. Experts say one of the next steps in hospital management will be to network all the portables and computers.
There's a great deal of interest in handheld or portable terminals using wireless local area networks to provide patient access. There is an advantage to having patient information in one location. The more important advantage is to be able to get to patient information from a wide variety of locations. Hence, a resident may not be on the nursing unit when he or she needs to provide another order, and hence can access patient data from perhaps their office or the resident's lounge.
For the Computer Chronicles, I'm Kate McGargy.
Let it never be said that doctors don't have a sense of humor. Here to show us a program called The Grateful Med is Dr. Bill Helvey of Medical Data Exchange. Also with us from the Dartmouth Hitchcock Medical Center in New Hampshire, Dr. Ed Schultz. Heidi?
Dr. Schultz, we patients all know that computers are being used in medicine for billing and the business of medicine. Can you tell us a little bit about what is being used from the doctor's point of view to help with patient care with high technology?
It's been a real change in attitude where we're trying to get the information to the clinician at the bedside or right near the patient in order to make the right decision with the best information available. Even the patient has been involved in this to put his value structure and sharing in the decision making. That's a big change in our medical care system.
Or Dr. Helvey, at your end, you're involved in helping a doctor access the gigantic amount of information I imagine is available on what's going on in the field of medicine. And how does Grateful Med help a doctor do that?
Well, Grateful Med is a software program which the National Library of Medicine makes available, so we can access Medline, which is the biggest database available to physicians and professionals. And with the database, with the software, you can do all of your work on your computer before you go online. Then it goes online, does the search for you, retrieves it, and you don't have to worry about making a mistake online.
So it's basically a friendly user interface for doctors who may not be computer
Indeed.
experts to be able to use this.
Right.
Now, what about from the public's point of view? I know you have something that a patient can access, not only a doctor, if you will.
Well, what one might call a mini Medline for the public is MDX Health Digest, and it's a database that is written, the abstracts are written for the public, not at a language level for physicians.
Or you have that online now, I
Yes.
think, so show us how you'd use that.
Okay, if we want to, say, take a look at what's available on Lyme disease, that's sort of been a popular topic. And specifically, we want to know if there's a article which will tell us both about diagnosis and therapy. And so we'll search. This is resident in the computer. We didn't have to go online. And
So you're basically doing a keyword search now.
that's correct. And we can also do it by index terms, but this is a word search.
And you could do it online. You're in fact doing it inside. You have the whole database sitting inside your
That's
computer
correct.
right now.
And it will be available online in CD-ROM, but any library or company or clinic that has a PC and has a 40 megabyte disk could house
All right,
it.
so what is the search telling you?
Okay, it's totaling now 4 articles, and we'll just take a quick look at the subject matter. This is from the University of Connecticut Health Center. It indicates both the diagnostic and therapeutic information. We have one from New York Times and Genetic Factors. We have one of the Medline abstracts from Postgraduate Medicine.
Okay, so if I wanted information about Lyme disease, I could go online to the service and pull down these articles
That's
just
correct.
like you did. Now, how do I access this service online?
Well, it must be stored. You don't go online to our center.
I see.
So you get it and load it in your own computer.
The entire database?
That's correct.
I see, I see. So you could then go to a library that has this loaded in?
That's right. Our GE's Genie network, for example, is putting it up.
I see, okay.
So you have those routes, both routes.
And how about the doctors who would want to use Grateful Med to access?
Grateful Med, if they would contact the National Library of Medicine at 800-272-4787, they can get information on how to acquire that software.
All right, Dr. Schultz, let's get back to you now. How are you using computers at the Dartmouth Hitchcock Medical Center?
Well, we're trying to bring the healthcare user into the loop more, giving them access to the information resources. The problem there is a lot of the information resources live on different computers with different ways to access them. To decrease that mental overhead, we're trying to make a uniform front end using HyperCard so that the clinician can sit there and point and click his way in a consistent way.
All right, show us how we do that.
For an example, we have something that looks like a medical record here. Tabs along the bottom are the same as a paper medical record, so he sort of has a metaphor of what to do. And just jumping in the middle of this case, let's go to this endocrine follow-up. This is a lady who had a suspected brain tumor. And he's talking about the lab test and says, look at the linked data. What we're going to do is branch to a HyperCard front end that calls into the laboratory system, downloads the information, and graphs it out for the clinician.
Now, clinician is what? Are we talking about a physician here, a lab technician, what?
It could be a nurse, it could be a doctor, it could be a medical student typically in our institution.
So what are they seeing?
Well, what they're seeing here is the interpretation of this would be that there's a suggestion that this guy should have gotten over the dotted line and that there quite possibly is a brain tumor.
Okay.
While we're here, let me show you some of the other things you can do. Typically, doctors think of tests in groups. They may think about the heart or the liver or whatever. Electrolytes, which is sort of the salt content of your blood, is often looked at. If you want to pick a different time interval, you could say, how about the last 3 weeks? And look at that. If you want to look at a different patient, we allow you to bring them up by the ward. Here's the intensive care unit. We can pick any patient there. And at that point, when we click on the button here, it then holds a conversation with the lab computer, downloads the information, and allows them to do it. Now, the problem we immediately had with this was it was too popular. We didn't have enough Macs in the ward, so people were queuing up in the morning before rounds and saying, I want to get my graphs out for 5 o'clock, 6 o'clock rounds. So we said, how about if one is able to say, I'm going to do it at 4 o'clock in the morning, beat everyone else. Graph, I don't need the numbers, so I'll get rid of those. And then 11 hours later, before I go home, I want to have the same thing done. Every day from now on, at 4 o'clock in the morning, 11 hours later,
you can automate that process, yeah.
They can pick it up in the laser printer.
Okay.
So the idea is, of course, you're using the computer less this way, but you're using information resources better.
Right.
Another thing that we've done to try to tune this to the individual clinician is saying, what if he doesn't like these panels? And a lot of clinicians feel very strongly about the way they do business, and they want to do it that way. We allow them to create their own panel. Here we'll clear the old ones and put in a new one.
And a panel is that combination of information, test results,
That's right.
or whatever.
And they'll usually be related together
Okay.
to give a particular answer that one test can't give. We'll call this a PBS. And this will go ahead and set up those 4 tests for a query. We want to do it right now. But more importantly, whenever I sign on, again, I'll see a PBS1, but only when I sign on.
Yeah.
This has been tailored to
So that's
the
our
individual
custom
clinician.
panel.
That's correct.
Okay.
Okay, so that's a gist of the major features of the laboratory package. Other types of things we try to do is again, if I want to go to the X-ray department, I should be able to address it in a similar way. The problem there when you go to the X-ray department is they give you a huge manila envelope, everything is in there, and it's difficult to find the films. If I just want to find the X-rays of this lady's head, I'd want to just click on the lady's head, see the types of studies that can be done, and here's a CAT scan. If I click on that, I get the information on what the radiologist has said on that. And finally, if the infrastructure is possible in that hospital, we could actually bring up the CAT scan and take a look at it.
All right, Dr. Schultz, let me kind of go back to Heidi's question in a way. Is all this computer technology just saving costs in the practice of medicine here, or is it improving healthcare at the same time?
Oh, I think it's clear that it's improving healthcare, and I think that the winners in the future are going to be the people that are able to effectively use computers to show that they can take care of patients better. I think that's what the government's looking at very closely now, too.
And Dr. Helvey, before we finish, I want to clarify with you, when you're looking at that MDX service,
Yes.
That may be available on some online services like Jeannie, you were saying, so you wouldn't necessarily have to go to a library and necessarily buy that whole database.
No, that's correct.
And if you did buy it, there's an update?
Yeah, monthly we'd send the update for
great.
the abstracts.
Thank you very much.
You're welcome.
Well, for an eye doctor, the diagnosis of retinal disease requires a close-up look at the veins and arteries in the back of the eye. Now, thanks to computers, ophthalmologists can do a better job using video angiography. Here's a report.
Good. Now down here.
Eye surgery is a delicate operation that requires extreme precision. Ophthalmologists at this clinic in Los Gatos are using a new video imaging system from ImageQuest to guide them in their work. A photographer uses the imaging device to produce digitized images of an angiogram. His machine is connected to a Macintosh 2 computer and a high-resolution video camera to capture the pictures. The images from the angiogram appear almost instantly on the screen.
The physician can review these within seconds of them being captured and actually can make a diagnosis virtually on the spot. Because these images are in digital form, they can then be computer enhanced. And in some cases, we seem to even see more detail on the computer enhanced image than we do on our classical 35mm photographs.
The images are stored in a HyperCard program. HyperCard allows the doctor to manipulate the pictures of the retina and enhance the portions he needs to see. They can be sharpened, brightened, and even colored to highlight the problem spot. The doctor can also print a 16-image proof sheet.
When we're obtaining the images immediately from the screen, we minimize processing costs, we have no darkroom costs, we have much less technician time involved in obtaining the results. And this is a significant cost savings.
Now, instead of waiting days or even hours, the ophthalmologist can diagnose the problem within seconds after the procedure before treating the patient's eye with lasers. For Computer Chronicles, I'm Elisa Clancy.
In the same way that flight simulators are a practical way to train fighter pilots without risking their lives, clinical simulations enable doctors to practice their skills without having to use real patients. Here to show us one such program is Professor Hurley Myers of the Southern Illinois University Med School. Also with us, Dr. Ralph Smathers, developer of the mammography teaching file. Heidi?
Dr. Smathers, with the explosion of medical information that's now necessary to teach the medical student, particularly in radiology, do you find that this type of technology as applied to this helps you fit all that in to the normal residency period?
Yes, on one laser video disc we have over 400 actual clinical cases with all of their mammographic images, and so several thousand images, all accessible in an interactive mode. And the student can review these on his own time, be it a medical student, a technologist, or a radiology resident, on their own time, go through all the cases before they actually begin the clinical services and be that much better prepared.
All right, Dr. Myers, now at Southern Illinois, you've got this DXR system you developed. Tell us about that.
Well, we've been working with the Macintosh computer and the HyperCard authoring tool to develop this simulation. It basically simulates the doctor-patient encounter. We call it DXR, or Diagnostic Reasoning, and we use it with our first-year medical students, although we've designed it in such a way that it can be used with a multimedia format so that you can do advanced students as well as doctors, but it is a simulator.
And what you have here, you've got a video disc player hooked up, a CD-ROM drive hooked up,
correct.
All into the Macintosh here, right?
That's right.
All right, show us how you would use it then.
Okay, well, this is the Christine Brennan problem, and we based this in large part on the principles of problem-based learning, which is used in a lot of the medical schools now to educate medical students. One begins or gets introduced to the case or the patient. Here we have a young lady that has dizziness, and now what we want to do is investigate this problem. And we do this entering into the case itself with a little bit more general appearance information. And now we've conformed to the HyperCard format, and we put buttons and icons in here, and we can ask the patient questions or do the physical exam. I'm going to go on to the physical exam component of this and show you some of the multimedia capability. We'll open up our doctor's bag, and inside our doctor's bag we have the doctor's tools, and we use those to investigate the patient. For example, if we wanted to take a look at the eye, view the eye, we would select this view tool here, click on the eye, and then we get a text response that gives us information about what we would see if we looked at the patient. On the other hand, if we wanted to look at the fundus of the eye, we would use the ophthalmoscope, select the ophthalmoscope, go over, click, and we have put a resource into the file here, and this shows us what we would see. We can then have the student or a user interpret this to provide us information as to whether they understand really what's going on. Also, we can go to another multimedia capability and use the HyperCard as a front end and go over and pick up an image off of a laser disc. Let's say we want to look inside her mouth here. And then we click here and get a look inside the patient's mouth. We'll go to the next view of the patient here, select the closer tool, go to the full body, get another view of the patient, and now we might want to look at some video that we've also have on the laser disc, and we'll select the motion tool and then go down and see the motion of the body. And this just gives you an example of how one would use this type to provide the multimedia format and then to give some data response to the physician to interpret. Now let's move to another view, and we'll show another capability in the computer here, and that's the use of sounds. To give you an example of where we put our buttons, we put buttons on here in the position that you would normally listen to the heart sounds. And we'll take our stethoscope here, select the stethoscope, and we'll go over and listen to the heart sound. And we can hear that there's a bit of a murmur in this patient, so that gives us maybe some idea about why her dizziness. It turns out she's got also an arrhythmia problem, and so we want to look at some lab tests now. We go to the lab button. We've got the most commonly ordered test shown here. For example, you can order glucose, get a response. And then we might want to go over to our list of categories here, and since this sounds like a cardiovascular problem, go to the cardiovascular list, and the Holter arrhythmia monitor might be of some value. We can select that, and if we're not sure about what that means, we can get test information, then order the test.
All right, Dr. Myers, I have to ask you to kind of wrap up here to move along. Now, what's coming off that CD-ROM that you have?
Well, the CD-ROM gives us a chance to look at the information that might be available to help a student understand what is going on with an arrhythmia of this type. So we go to our learning resource, take the textbook off of CD-ROM and select that. And then we get into actually a CD-ROM that has textbook information. We can go to the table of contents, and then go to the cardiovascular section and look at this.
Okay, Dr. Smathers, as you're using similar technology in the mammography area, tell us what the mammography reference file and teaching file is.
Well, it contains over 400 clinical cases with 2,000 images, and it also contains live video clips that can show the positioning technique itself.
Again, used for training doctors.
Yes, for technologists, physicians, or medical
And what have you
students.
just done?
We're showing an active live segment from the video disc with audio and video, and showing the actual positioning, the taking of the breast X-ray itself.
Okay.
I think it's important for the physicians to know the process of how the images are obtained as well as how to read them.
Okay, now what do you do once you get these images? How would you use your program to analyze these X-rays?
Well, what it does is we can go back to the teaching cases and actually look at some sample cases. Section 1 is normal anatomy, and we can demonstrate a normal mammogram here with the white areas being dense parenchyma and the darker areas fat. The individual areas can be indicated with graphic overlays, fatty replacement, and even a small fibroadenoma, which is an abnormal mass. Then we can also go into other areas of disease. Section 4 is masses, and look at an example where we have here a shaggy ovoid mass.
And again, all these X-rays are coming off the video disc.
These are being drawn straight from the disc to the display, and these are all abnormal lesions, the majority of which have been biopsied for pathological proof. This one is a cancer on the far lower right of your screen, and this is another mass. So the student gets familiar with the features of a mass and can tell benign from malignant disease. Another area would be calcifications, and one can certainly show those quite well. Here are abnormal blood vessels inside a mammogram. Also, one can get out and simply look for, by diagnosis, keyword search. For example, I'll just type in fibroadenoma, and it suddenly found 15 cases from those 400 on the disc, and has allowed us to be able to view.
So that just pulled up the 15 X-rays that are sitting on the video disc
from the laser video disc database, and this here is automatically showing examples of those cases.
To the doctor in training here, what are the advantages of this kind of system over what took place before that?
Yes, before one had a large series of film files that were in various doctors' offices or in a teaching file somewhere. They were very difficult to reproduce. Mammograms are high-quality images, and it was difficult to get good copies in different places. This provides a standardized way of teaching mammography. It's also extremely comprehensive. It has every possible diagnosis in breast disease with mammography on it, and the student can get through the entire area very quickly.
Gentlemen, thank you very much. That's our look at computers in medicine. Stay tuned now for this week's Computer News.
In the random access file this week, Apple says it's cutting the prices on some of its high-end and mid-range Macintosh computers by as much as 31%. Some of the models affected include the Mac 2 FX with 4 megs and a floppy drive. That's been reduced to about $7,400. In the mid-range, the Mac SE 30 with 4 megs and an 80 megabyte hard drive will go down to about $3,800. Software Publishing has introduced a new word processor for Windows that includes an integrated electronic mail front end. The program is called Professional Write Plus, and it lets you send or receive mail messages and file attachments without exiting the program. The document processor has a grammar checker that proofreads documents in 6 different writing categories, including business, technical, and fiction. Professional Write Plus also features a spelling checker and thesaurus. Central Point Software has announced a new virus protection program it claims will detect and eliminate more than 400 known viruses in DOS, Windows, and networked applications. The program is called Antivirus, and it can run as a standalone application to diagnose and repair existing viruses, or it can be loaded as a memory resident program to detect new viruses on the fly. Central Point Software also announced a new support program that will provide customers with a 24-hour virus hotline and updates on recently discovered viruses. Next up, Paul Schindler and this week's software review.
I'd love to be a teacher if they brought back corporal punishment. But seriously, for those of us who weren't paying attention in school, or even those who were, there's some more help on grammar checking available from Correct Grammar. It includes a spelling checker, but there's lots of those. This one works pretty well. More impressive is its ability to check capitalization, verb tenses in context, homonyms such as there and there, and punctuation. If you wonder why it suggests a correction, ask it. If there are certain grammar rules you just don't care about, move to another screen and turn them off. In addition, the program shows you each correction as it goes along, offering you the chance to disagree or just plain overrule it. The program can also find colloquialisms, wordiness, spacing errors, and split infinitives. There are some things up with which it will not put. Correct grammar is $99 for the Mac or the PC from Lifetree Software in San Francisco. For the Computer Chronicles, I'm Paul Schindler.
Taking a look at this week's top 10 software titles for the Macintosh, Mac Connection reports that Mac Utilities is in the #1 position, with Macintax 1990 in second. Third is After Dark, followed by Sam and Disk Doubler. Rounding out the top 10 are Quicken for the Mac, Microsoft's Word, the Microsoft Office, Adobe Type Manager, and Excel. Adobe Systems has announced a new font technology called Multiple Master Typefaces that lets you manipulate the weight, width, visual scale, and style of any font. Normally, typefaces are individually produced by the type manufacturers and sold as fixed static fonts. Adobe says its new technology will now let you buy a single font product and then personally generate an infinite number of font variations. Aldus Corporation has begun shipping Freehand 3.0, a new design and illustration program for the Mac. New features include movable on-screen palettes that list the line and fill colors, graphic styles, and layers used in creating an illustration. The upgraded software also has flicker-free drawing and a screen redraw time up to 5 times faster than the earlier version. You can now turn your computer monitor into a touchscreen input device using a new product from Edmark Corporation called Touch Window. It can be used for most software programs that support a mouse. The Touch Window will fit on any color or black and white monitor up to 15 inches in diagonal size, and it can be removed and used as a separate graphics tablet for drawing, testing, and touchpad input. That's it for this week's Computer Chronicles. I'm Kate McGargy.
The Computer Chronicles is made possible in part by the Software Publishers Association, which reminds you it's a federal offense to copy software. The SPA provides information on how to stay software legal. Funding is also provided by PC Connection and Mac Connection, and by Byte Magazine and Bix.